Hello, everyone. Great to see you all here. So let's go ahead and start today's presentation. The presentation is Designing Jewelry for Manufacturing with Rhino 6. This webinar is for anyone considering using Rhino for jewelry design. Our presenter is Gary Dawson. He is a jewelry designer and goldsmith. Gary has nearly 45 years experience in creating and producing jewelry designs. He is a frequent contributor to the MJSA Journal. He is a founding member of the Council of Custom Jewelers, and he is designated as a mentor jeweler. And Gary uses Rhino to do his design and analysis for fabrication. He is also an authorized Rhino trainer and uses the latest version of Rhino 6 for Windows. He has delivered seminars and presentations at numerous events, including the GTA Gem Fair, the Portland Jewelry Symposium, and most recently the Santa Fe Symposium on Jewelry Manufacturing Technology. He is also a technical columnist for the Jewelry Business magazine. And myself, Mary Fugier with Robert McNeil and Associates Technical Support in Seattle. I will help facilitate today's presentation. I have a few items to cover before passing the presenter role over to Gary. Let's start with the schedule. The presentation will take about an hour and a half, and then we'll open up the mics for any questions. The first part of the presentation, Gary will share details about his work and then move into a live technical demo using Rhino 6 to design the ring that you see in the lower left corner. Tips and tricks for using Rhino will be highlighted along the way, and Gary will show how Rhino 6 is used in jewelry design with a focus on manufacturing. Gary strives to bring manufacturing consciousness into jewelry. From the very first curve he makes today in Rhino, Gary will illustrate how a well-designed jewelry piece will have both an aesthetic and structural integrity. With that, let me just show you Gary's websites. This is Gary Dawson Design. This is Rhino Jewelry CAD, and this is our website for the webinar. And we'll add the link to the video out here. So if you have to leave early, you can hit this website for the video. Okay, so we are ready. Let's go ahead and welcome Gary Dawson as presenter. Hey, Gary.
Hey, Mary. Thanks for your generous introduction. I still don't get how the math works because how can I have nearly 45 years of experience
when you're so young?
I'm only 35 years old.
It's funny how that happens. But thank you, Gary, for all your work putting this presentation together. And we are looking at your screen right now. I will try to keep up with question answers, and if you're ever curious what questions are coming in, just go ahead and ask, and I'll break in if there's anything important that we have to get to. So okay. It's all yours. Thanks, Gary.
Yeah, thank you, Mary. I appreciate it very much. It's been a lot of fun preparing this, actually, and I get to rail on some of my favorite current topics about things that are going on and digital design and the jewelry industry in general. It's nice to have a bully pulpit for a minute or two. And let me just add, I'm totally open to questions pretty much anytime during the presentation. Of course, we have to move through the process here, but I may in fact do a better dialogue than I do a monologue. I'll try and keep up with myself here as we go along. But so you're seeing my screen right now. Upper left-hand corner is formers and a shaded view, and then a finished ring. This ring actually got some recognition in an international design contest. SolidScape periodically runs these design competitions, and I didn't win that particular one, but it got an honorable mention or some such award. So it was pretty gratifying. All in Rhino, and I would have to say that I did that design. Gosh, it's been at least a year ago now, and my skills have sharply improved since then. One thing that amazes me about working in Rhinoceros is that even with nearly or maybe over 8 years of experience, in at least a year of, or very near a year now of seeking accreditation and going through yet another learning process with Rhino, just about every time I open it up, I find new things that that are useful to me in my design business, and it's really fun to be able to share that in my instructional process too. So why did I adapt to this technology? I guess I've always been one to adapt newer technologies, or at least check them out and see if they're appropriate for myself. I have evolved now to say that there will always be a market for extremely well-made jewelry. In fact, my degree's in anthropology, and I read somewhere along the line that every human culture, from ancient to current, wear some form of jewelry. They wear body adornment. So it's important to the human experience, jewelry is. And well-made is important also. You know, if wax carving is your thing, then by all means do that. If fabrication is your preference, do that. I do think that digital design gives one a competitive advantage these days in jewelry design. There's sort of a feedback loop that goes with designers and consumers have now begun to expect the precision that is possible through digital design. And I think, like I say, it gives you an incredible competitive advantage when you can offer that as part of your toolbox. I still fabricate, I still carve wax models, but I'm real proud to be able to offer this too. So moving on, today we will look, let me see why this isn't clicking now. There we go. Okay, the first thing I want to mention, if you're completely unfamiliar with Rhino, we're going to be working in 4 viewports here. From the upper left, the top, perspective viewport, front and right. And once I actually get into Rhino itself, I'll go through this again very briefly. One thing to watch out for is that the perspective viewport tumbles. And I can't demonstrate that here because this is a static slide, but it can be disorienting. You know, if you're focused on this perspective and I start to tumble it, hang on to your chair, because it can actually be an issue for some people. We will begin. I'm going to start this project from scratch using basic formers, a circle and a cross section to form a shank. One thing I would like to emphasize now, and hopefully I remember to bring it up throughout the process actually, is that part of my instructional regime is to really encourage people to think downstream. Manufacturing consciousness is sort of the little tagline I have on my website. And the idea is that if your piece is going to be cast, as most things in the jewelry industry are today, then you have to think about that process as you're doing your design. What's casting friendly, what won't work, what will work. And so then once we get into it, we're going to sweep this rail with a cross section, and then we're going to use history to modify the shank that we're going to create, and I'm going to show you how that works. I will show you a simple technique to use precision modeling to form cutters and little prongs, and the gemstones are actually, you can't see them here, but they're embedded within the cutters. And here we're gonna flow from this curve, you can just see the end of it, to a subcurve of an isocurve. And those terms hopefully will become familiar to you if you don't know them already as we move into this process. But we can form these things pretty rapidly and then flow them wherever we want them onto the piece of jewelry using a flow along curve command in Rhino. And in this case, I just have the gems demonstrated here, but everything goes, and it goes pretty fast. We're going to talk about forming complex surfaces like the in tab sort of bezel, partial bezel I have here for the marquee shaped stone. We're going to be playing with that design. And matter of fact, oops, I didn't mean to go backwards, and let's see if I have a backward button. Yeah, I didn't mean to go forward yet. Building solids, I'm also going to demonstrate wire cut, which is actually relatively new to me, although apparently it's been there since Rhino version 4. Part of my ongoing process, kind of like a Boolean difference, except it can be a little faster because you just use simple curves to do a Boolean cut on a solid. And then we'll talk briefly about rendering, how to make materials, and we'll discuss some of the different modes in the viewport that you can use during the modeling process. And I just want to show you before I jump into this where I get my numbers. This is a spreadsheet that I created for myself that does diameter and circumference comparisons for sizes, US, Canada, UK, Australia, Japan, and China. Not all these systems are similar to each other. And the ring I'm going to be making, I decided, I guess, it would be a size 7, which means that it's going to have a 17.32 millimeter diameter. So I just wanted you to know where I got that number. And I thought that I would make this as a PDF available to all of you after the webinar. Mary, it's not there yet, but we're going to debrief after this, and we'll put this on the webinar webpage. I think that's where it's going to go, right, Mary?
Yeah, Gary, what do you have, a PDF of it?
Yeah, I have it in PDF.
Okay, super. Yeah, we'll add it to the landing page, and then anybody can download it. So
I thought that'd be easier.
Yeah,
than
perfect.
Everybody might not have. Okay, so that's the end of the slideshow. Let me get this thing at least minimized, and I'll bring this up.
Hey, Gary.
And yes, ma'am.
I just wanted to make sure you were still hearing me okay. In case there's a question, I can let you know. But okay, just a little jittery after my mic this morning. So okay.
Well, you know what? You made me feel more comfortable after I blew it
man.
during the practice section.
I mean, we did so good practicing, and then my mic just went out to lunch. So anyway, nothing like a good fresh start, right? Thank you.
Well, and there's nothing like live presentation. You guys that are here, all 67 of you now, will have the opportunity to see the good, the bad, and the ugly.
Yes. I love that.
You know, I make mistakes in my modeling process. I'm not that precise, and always, at least. I try and be, but you know, you make mistakes. I'll show you how to back up out of them. Before actually I start modeling, I do have a couple more things to show you here really briefly. Did you have something to say, Mary? I didn't.
I just wanted to let everybody know, Gary, that you're in Eugene, correct?
Correct.
Yeah,
Eugene,
okay. I didn't know if you changed your location, but
right.
I'm in Seattle, and one thing that's really great about being remote from each other is that I can hear you appropriately, you can hear me, hopefully. So if you're not able to hear Gary or me, then you're going to have to adjust your own volume, because the broadcast is working appropriately. So there was one attendee who said that the volume was not coming over, but we don't have that type of control. It's just the machine. Your computer, right. You're going to have to turn up your volume. Okay, there you go. Thanks, Gary.
Yep. Yeah, after a minor technical glitch in the beginning, I think everything's working just fine right now. So yeah, before I dive into the actual design, I just want to talk a little bit more about that manufacturing consciousness and thinking downstream. And that has a great deal to do with filleting and blending surfaces. If you see on my screen here, I have a block and a pipe, and I have them joined here, and you can see the surface join. And if I rotate this, and here's an example of that tumbling perspective screen, by the way. Hopefully your connection is good enough so that's a smooth movement for you. I will be also clicking between these screens pretty rapidly during the presentation. So, you know, if you're unsure of where we are, you can look in the upper left-hand corner here of the viewport to see what screen we're in at any given moment. I'll try and do a lot of my work in perspective, but I will be jumping into top, front, and right views also. Okay, so getting back to this, you could think of this actually as part of a sprue system. If this is the jewelry object that you created and this is a sprue attachment, if we align this just right, you can see how on the left-hand side here, this makes a 90-degree connection. And if you think about negative space, okay, the block and the pipe are solid objects until burnout happens in the casting process. And then this is negative space, and everything around it is the investment, the positive space. So imagine the casting process. We have high density metal, high density fluid coming up here at very high velocity. And this little sharp edge of investment oftentimes will have a tendency to break off, and it'll get lodged up here somewhere in your object. Now, if it's lodged in the middle of a solid piece of gold or silver or platinum, you may not ever know it's there, and it might not create a problem. But a lot of times these things get lodged on or near the surface, and then that's a big thing with pits and porosity. Okay, on the right-hand side, you see the way to make that better. You got to think about fluid dynamics and turbulence in the casting process and not leaving really sharp edges at surface junctures. One thing I'm glad I remembered to mention just now is that the people are mostly, I mean, I think probably a lot of people are using resin printers, whether it's SLA or DLP type printers. They create a photopolymer resin model. And that is very popular in the industry right now. And while it is possible to cast resins, it is somewhat challenging. There's a little bit of a learning curve. But something I've discovered, I see on the forums, I see a lot of people talking about problems they're having at sprue junctures and just voids in their casting. And I think a lot of the problems that people are attributing to resins a lot of times are engineering problems. Because when we're carving waxes, I think we sort of just automatically practice decent engineering because it's pretty hard to carve a perfectly sharp angle. But CAD leads itself to that. I mean, it's easy to do this kind of precision and sharp geometrics in CAD. And so we see problems showing up that people are attributing to casting resins that are actually engineering problems, because I think resin tends to exaggerate any engineering problems that you might have and be unaware of in your casting system. So that's part of the whole manufacturing consciousness thing. So I'm going to go ahead and get rid of that. And I'm going to bring this one over here, and I'll just show you a real example of this is actually a design that I did for somebody pretty recently. This nice lady wanted something very simple, you know, simple bezel, just a little fluid movement in a ring. And so this was the original iteration. But you can see right here, this is potential for huge problems in the casting process, right where this comes to a very sharp, acute angle right here. If you picture that in negative space, that's a knife edge. Metal's going to be rushing up here really fast, and some of that's going to break off, almost guaranteed. There's another little problem over here. And then where these things meet too, because this is a pipe, a round cross section meeting a straight surface here, this juncture too is problematic. So the way I solved that, I did this mostly with a command called blend surface. And it takes a little bit of patience to get that to work on complex surfaces sometimes, but you can see how even though this surface meets this surface at a fairly sharp angle, there's at least a little bit of a radius here where they actually come together. And I've created radiuses here and here, and this cast very well in this situation. No real problems. I could have actually gone on and filleted this edge. There's, you know, there's always things that you miss, but you try and do the best you can when you're doing this. And by blending surface or filleting surfaces, you will probably enhance your results considerably. Does anybody have any questions about that particular aspect before we move on? Yes, actually. I'm going to save that. Okay, so we're going to move on to the actual...
Hey, Gary.
Yeah?
Yeah, there was a question back about your chart as to whether it included shrinkage in the chart.
No, as a matter of fact, that's what excellent timing, because I'm going to address this right now. So what was that, 17.32? Let's go ahead and make the circle in the front viewport here. So we start at 0, 0. I better turn on grid snap to get there.
We'll and then there's actually 2 more questions related to that model that you just showed. If you want, I'll read them to you.
Okay, sure.
David says, would you then hand work to a deeper and more rigid or more refined edge?
In other words, if you wanted a sharper edge in the finished process, then yeah, you could take some little sharp files and go back down there and refine that edge. But you know, I already X'd out of that.
That's okay. That's
example,
okay.
But
yeah.
But I can visually, I think I can verbally talk you through that. The thing is that you got to remember, when you look at something on the computer screen, and this is something you constantly have to educate clients about too. You send them a rendering, and they put it up on a 32-inch computer screen. Those little details, you know, those blended edges that you saw on the ring I saw, those are not necessarily going to look very mushy once it's printed and cast. So I'm not sure that it would really be necessary to go back in and define those. But yes, absolutely, you can go back in and redefine surfaces if you feel that you need to. But you got to remember that the perspective you get from looking at a big computer screen during the design process is going to be different when the entire object is only 17 millimeters wide, you know. Hopefully that answers the question. Did you have another?
Yes, the other one is from Ted, and he says, can't you just use ZBrush to fill it?
Well, yeah, you can. ZBrush is an option. I know several good designers that actually go back and forth between Rhino and ZBrush. Some people do their entire design process in ZBrush. For me personally, I have a real hard time with the interface of ZBrush. I've owned a ZBrush license probably for 3 or 4 years now, and I have to say that my learning curve there has been incredibly slow because I can do just about everything I need to do in Rhino, and for some reason the interface just is a lot more intuitive for me. And the other thing I would mention about that is that hang on to your seats, because sub-D modeling is coming to Rhino pretty soon. I'm not sure when version 7 is due. I'm not sure if we even have a launch date yet, but sub-D is already built into the demo version, or not the demo version, but the beta version of Rhino, which is available to anyone. Correct me if I'm wrong, Mary, but I think anybody who has a Rhino license can download Serengeti, which is what the beta version is always called, and sub-D is already there.
Yeah, that's a good point, Gary. So it's under development. Anyone who owns Rhino 6, so you will need a Rhino 6 license to become part of the beta of Rhino 7. But even as we speak, the sub-D tools and commands are still being typed on. So it may not be the time quite yet, but I would say in a few months, as we move more towards fall, and of course towards the end of the year, we'll be making those features more known, and they'll be more refined and closer to production at that time.
Right, right. Well, that's pretty exciting though too. But I mean, the thing is that blending surface and filleting, I mean, fillet is a command in Rhino, so it takes like a second to fillet surfaces. But for more complex surface junctures, blend surface tends to work a lot better, it seems like, for me. But I mean, it doesn't take that much time, so you can do all of this right in Rhino.
Okay, thanks, Gary. We're all caught up now.
Okay, good. And thank you guys for your questions and participations. I really love it. Questions tend to lead into tangents and allow for more learning, in my view. Okay, so to go back to, so we have the 17.32 millimeter diameters circle, and then shrinkage is the next thing I was going to discuss. Actually, in the practice session here, first let me just do this. We're going to transform, scale, 2D, and I find that for the shank itself, to accommodate my particular process, and your results will vary, I scale by about 1.1%. So I'm gonna scale factor for me starting at the center is going to be 1.011. 58 actually is the number I use, which sounds weird, but I got that from a Santa Fe Symposium presentation. But so when I did this in the practice session, Travis piped up, who is there participating with Mary and I and helping us refine this whole thing, suggested that it would be easier to maybe do the complete model and then scale the whole model up the amount appropriate for your system. And at that point, I thought, well, yeah, that's a really good idea. But later on, and I continued this conversation with Travis in an email conversation over the last few days, is that what I notice in my particular process, and again, I want to stress that you're going to have to do the experimentation with your printer and your casting process. But I see a different scale factor necessary for different parts of objects that I create. To explain, like this 1.01158 scale factor works perfectly for shanks for me. If I do that, then it'll pretty much come out right on a 7, or actually it'll come out just under a size 7, which is what I like, because I like to, once the object is cast and I clean up the inside of the ring, I'll usually pound it with a rawhide mallet to make sure it's perfectly round and to slightly harden the metal of the ring. So my goal is to have it come out just slightly under. And I think that that's a pretty good practice. But with bezels, for example, we're going to see this in a little bit. I usually offset the gem size by 0.4 millimeters to create a bezel, depending on the size of the bezel. But that works pretty good. And I find that about 3% scale factor works a lot better to ensure the gemstone fit there. So rather than scale the whole thing, I mean, for now, unless I, if I were moving to CNC, like a 5-axis, I'm totally jonesing for a good 5-axis mill right now, which I don't have. If anyone would like to contribute, I accept everything from Bitcoin to to bullion. But joking aside, if you're actually carving in wax, a scale factor is a little less important. You still have to scale for the casting shrinkage, but you don't have to worry so much about resin shrinkage. Also, with the piezoelectric wax printers, SolidScape is one example of those. The scale factor for the model itself is much less important. So hopefully that answers the question about scale factor and how I tend to approach it for my system. And again, I would have to say, for the third time, I think that's real specific. Okay, so we have this thing, we've scaled it, and the size is going to come out just about perfect. We're going to move to the right thing here and create a cross section. So I will make sure that I have quad on as an O snap, because I want to snap to the very bottom of this thing, and I'm just going to use a straight line snap here, and I want to make my shank 3 millimeters wide, because the gemstones that we're going to be setting in here are going to be about 2.5 millimeters in diameter. So I'm going to do 1.5 millimeters in length, and I'm going to shift ortho And then I'll come down 1.2 millimeters, and again, shift ortho here. Okay, boop. If I could release that, okay. And then I'm going to mirror this on the y-axis, and then I'm going to do an arc from end to end, and I'll bring this up to about here. Okay, then we'll join all these, and then here's our manufacturing consciousness. Rhino has a real convenient thing called fillet corners for curves, and you'll see that this fillet radius of 0.2 shows up because that's the one I use probably most often, and we do this, and so that is going to automatically fillet the edges as I sweep the rail for this thing. Now you can go back in if you've created sharp edges on a shank or something. You can go back in and just fillet the edge in the solid menu here, fillet edge right here, boom. We don't need to do that right now though, but I will try and remember to demonstrate that a little further on in the process. Okay, this is going to be the rail that we're going to sweep one rail. We're going to use this as a cross section. Drag seam point, I'll accept that. And we want to use road-like here, and I'll explain why in just a second. And I think we can just accept that and it'll be fine. All right. So now I'm going to ghost this, and I'm going to select this curve. If I can find it, boom, there it is. All right. And so we have 1, 2, 3, 4, 5. We have 8 control points here. Now the shape that I want this curve to assume, because I have history on, that's located down here, by the way, record history, is going to require a few more control points. So I'm going to rebuild this real quick. I'm going to double the point count, and I'm going to make the degree 3, which means that the curve will become smooth with no kinks in it once I move it. So we'll do that. And now I'm going to grab these 3 control points, and I'm going to move them -2 millimeters. And then I'm going to grab this, oops, that's what to do when you make a mistake. Where's my curve again? There we go. And control points show up. I'll grab this one and move it -1. All right. And so you can see how we have a really nice fluid curve, and we've done that with history, and we've rebuilt the curve to accommodate the sort of shape change that we wanted. Now, I told you I would explain the difference between road-like and freeform. If I would have left this in freeform, this would have still distorted the shank just fine, but it would have tilted the interior. I just started to motion with my hands to show you a tilt, but this interior surface would have leaned just a little bit, and it would have taken the rest of the ring with it. And so we want to keep this nested against the finger without any pressure points. So that's the road-like versus freeform in this particular case. All right, let's just hide this for a second, and we're going to select both of these, and we're going to put them on a layer so that we can, and that layer is already hidden apparently. Boom. Okay. So, actually, I had already, this is the finger size itself, and I usually like to keep just a circle that is the finger size, because we're going to use that to create cutters a little bit later on. So now we have both the finger size, which you can either make another circle or just copy this one and then distort the second one. So we have these all on their own layer, and we can hide them or we can bring them back pretty much at will. All right. So let's go ahead and hide them and bring this back. And now we have, let's see, let's go ahead and make our gemstone cutters. Let's set up our flow. And we will do this, I think, first of all, yeah, let's go ahead and hide this. And we can do this in the top viewport just so you guys can see what's going on. And we're going to make a 2.5 millimeter 2.5 millimeter diameter circle. Okay, and then we said we were going to scale this 3%, right? Let's go ahead and do that. Transform, scale, 1.03, boom. Okay, so that's scaled up. Now this, actually I just realized that for downstream, the way I have this plan, that may mess with stuff just a little bit, but we're going to head and offset this, and we're going to offset it by 0.4 millimeters, boom, just like that. And now we're going to move to the front viewport, and I'll show you how to use precision modeling to make a cutter pretty fast. So we're going to start at the quad of the inner circle. See, that's the inner circle there, and here's the outer circle. So we're going to start here, and we're going to use a relative position of negative 0.4 with an angle of 41 degrees. Boom. And see how that placed the second point of this polyline, negative 0.4 millimeters, and then an angle down of 41 degrees. Now, the reason I chose 41 degrees in this case is that the pavilion of most faceted gemstones, in particular round diamonds, are very close to 41 degrees. I think, I can't remember exactly, but they range from 40.6 to 41 point something or something like that. But 41 is pretty much right in the middle there. So this will now match the pavilion angle of the round diamonds that we're going to use in this design. Okay, so I have grid snap on. If I were to just click on the grid, you can see that this line is not going to be straight down from my last point. So I'm going to shift ortho and come down here. And it doesn't, in this case, it doesn't really matter how far down I'm going to come. So I'll just, because it's going to be a cutter, it just needs to extend through the ring shank that I've created. So I will shift ortho, boom, and I'm going to come over using Smart Track to hover over this and to make sure that shift ortho is on. And this is the intersection now. What that does is make sure that I line up with this, with that outside. I line up the last part of that point polycurve with the outside quad point, and I'll show you what this looks like in perspective view. Okay, so here's what we have right now. Okay, so we can select these surface, sweep two rails using this as a cross section, boom, and we have okay. And now we can take, wait, am I doing this right? I'm creating a bezel. Sorry, guys. I told you that's the beauty of live presentations, right? I'm going to Control Shift select these two parts of the line and delete it. Oops. I'm going to Control Shift select these two parts of the line and delete it because I'm creating a cutter, not the bezel at this point in time. Right? Okay, so this surface sweep one rail, this is a cross section, boom, there. And then we take this line, sorry for the confusion, and we extrude it. And then we join these two surfaces, Control J, and we cap them. Okay, that's our cutter. I guess in my mind, I was creating a bezel. And basically that same process that I did, and then you extrude both lines up and then cap them, and then you have a bezel instead of a cutter. Okay, so we actually don't even need that right now. I went through that whole process without actually needing it. Okay, let's hide this for a second. And oops. What did I do there, Mary? I locked it, I think.
Yeah, that's it. Right click on.
There we go.
Oh, Gary.
I get ahead of myself so often. Okay, so we're gonna. I already have created a layer over here called round cutter. I did some prep work this time, so we'll put these here, and we will whoop, delete that, and then we'll bring back everything. So we have these cutters. Okay, so I'm going to take this cutter and I'm going to move it 20 millimeters in that direction. Oops, unknown command. Oh, here we go. 20. There we go. And that will line this up now with these grid lines. And you'll see why in just a second. Okay, so and actually, let's do this. I've got a round gemstone hidden here somewhere. Round gem, here it is. Boom. I'll bring this up, and it is here. It just appeared, and I'm going to move this. Oops. What? There we go. What? Okay. I'm going to line this up perfectly with this cutter. And you can see how, oops, I need to, actually it's, seems to be a little small. So we will scale. That should be about right. Let's look at this in top view. And let's make sure it gets lined up here. There we go. I'm going to scale that down just a hair. And that should fit inside the cut just fine. All right, so now we have a gemstone and a cutter in place. Now what we need to do is start working on our prongs. And we can do, oops, I'm going to put that there, actually take grid snap off. Let's make this perfect while we're at it. There we go. Perfect. All right, we need a prong. We're going to just use this end, and we're going to come up, what, 1.5 millimeters? Should be about fine, 1.5. Boom. Okay, so the separation we want to have between these, I'm trying to remember how I did it before. I think it was 0.15 millimeter in terms of separation between the gemstones. And so we're going to move this former for the prong that we're going to make. We're going to move it, and Rhino does math, by the way. So if we want to move it negative 0.15 divided by 2, we could have probably said that's 0.07, right? Or 0.075. But Rhino can do the math for you. If you've got a complex situation that you don't necessarily want to try and figure out in your head, or do the math on a calculator at a diameter. See, now we're on radius, so we want diameter of 0.44, boom. Let's look at this. Looks right. That looks small for some reason to me. I wonder if we made, what do we got here? 2.5, yeah, that's 2.5. The gemstone's 2.5. This looks smaller than it should. I'm going to delete that. What are we going to do here? We're going to pipe this at start diameter. Yeah, that should be good. 0.4, enter, enter. There we go. Okay, and so if we move the curve, that will follow. We actually don't even need the curve anymore, so we can delete that. I'm going to scale that up just a hair, because for some reason that's not looking right to me. All right, that's about the right position, because we want this, we want the prong to intrude into the cutter space just a little bit, because we'll want to actually cut prongs. Doesn't need to be nearly that long. So let's do that. Okay, and then we're going to mirror this object on this axis. Make sure everybody can see it, have grid snap on, boom. All right. All right, so now we have the beginnings of all the stuff that we need in place. I am going to hide this. And let's see, I got rid of my cutter lines. That's one of my favorite tricks, is to take all the lines that I've made with me when I do this. Okay, so now we want 7 of these stones. And so it's 2.5 with a 0.15 separation between them. So 2.65, we're going to grab all of these. We're going to do a linear array, and we're going to do 7 items. And it doesn't really matter where you start here. We can start right here, and we're going to be doing them 2.65 millimeters. Boom. Oops. And we want to shift ortho to make sure they're all lined up. All right. Now we have everything in place that we need to flow, except we need one more set of prongs there. So we're going to alt copy those, and we're going to do them 2.65. Boom. And that copied everything. So now we have everything we need. Okay, so now we're going to make a line here that will be our flow line. Or actually, let's get all this stuff. For some reason, I like to work with stuff centered. So let's take all of this stuff and put it right on the y-axis, and we'll move it up here so that it's pretty well centered on our view screen here, and that'll be centered with the 0, 0. Now we create this line that will extend here to here, right? And this is going to be our baseline for the flowing process that we're going to do. And that should work pretty well so far. So let's find out how long this line is. We'll analyze length, and 20 millimeters. I've done something horribly wrong here, because that should be, no, maybe it's because I scaled. I think in the past I haven't scaled this. So this will probably work out. We may end up actually eliminating one of these to make it work out in the design, but let's see how far it goes. Like I said, live presentation, we may have issues to deal with here. Bring this back. Oops. And those are already flowed. Let's go ahead and delete those guys. I didn't mean to have them. Okay, so now we're going to flow these along an ISO curve that we're going to create. So we're going to extract, extract ISO curve from this surface, and we want this right along the midline. So we're going to click here and then enter to accept that, and that gives us an ISO curve along the outside surface of the shank that we created that follows the contour perfectly. That's very good. And so this was 20 millimeters, right? So we're going to make a subcurve out of this ISO curve. We're going to, create ISO curve here. We're going to use the curve edit tools, make a subcurve. We're going to start at the quad, and we're going to go 10 millimeters, because that's half of 20. We can do that math, right? Boom. And then we're going to mirror this on the y-axis. We're going to shift select and control J for join. Okay, so now this line, which follows the contour of our shank perfectly, is the same length as this line. So let's see what we get when we try a flow here. We're going to take all of these objects except for this. We'll deselect it, and we're going to transform, flow along a curve. And we're going to use this as our base curve, and we're going to use the subcurve that we just created here, and watch what happens. Boom. Okay, now I've done this perfectly. Notice, because I want to show something here about that selection, and this ties up a lot of people. Notice how it stretched these objects along the curve. which isn't okay because our stones are round, right? So we're going to back off of that. We're going to reinitiate that command. And this time, see right up here, we're going to say rigid. So we're going to keep these objects rigid. Base curve in here, and look at that. Beautiful. Okay, so now we use history to adjust the objects that we want to adjust. I think we can take all of this stuff except for this curve. Oops. See if I can get it that way. Deselect that. Okay, so the curve is not selected. So I want the girdle of these stones to be down right at the surface where it meets the edge. So we can, let's turn off grid snap so we can do some fine adjustment here. We'll just move everything. And see, it's still, yeah, we got to go down quite a bit, looks like. And it didn't take the gemstones with us. You know, I wonder if it's because I deleted, I bet it's because I deleted the other ones that might have broke history on the gemstones. I'll bet you that's what happened. Well, that's an easy fix. Okay, so let's just select these guys. And we'll delete them. And then we'll select these guys. And we'll reflow them, which will reinitiate the history here. So we're going to transform, flow along curve here, and where's our subcurve here? Boom. Okay. So now history will work. There we go. Perfect. Not quite where I want them. And actually, I'm going to select these guys also, except for that. And I'm going to just watch now as everything goes down to right where I want it. That's a little too much. There we go. I think that's about ideal. And the cutter, yep, good. Okay, I'm happy. The only thing I want to do probably is to select, see if I can get those and not get all the gems. Okay, I'll have to deselect these guys. Oops. Really quickly. There's once we get these flowed, then we can group these things and use them as a group instead of having to, or we could put it on a layer to deselect and unselect. Oops. I'm going to undo that because I still need to deselect this line. What am I doing here? I'm trying to get these guys. That's what I want. Okay. And then deselect. Now I have all the prongs. And we'll move those down just a little bit to be a little more realistic. Okay, now we're cooking. Now we're cooking with gas. Okay, so now let's move this to a shaded viewport since we're done working with those lines and whatnot. And we can do a Boolean difference here. We'll select this object, Boolean difference, and we'll use the cutters that we made in position. Boom, right? And then we can put all these on a cutter layer. Let's go ahead and make that layer. And we'll put those on the cutter layer that I just made. And we will hide that layer. And then we should have a beautifully formed shank with the gemstones in place. Looks like I could move those gemstones up just a little bit for rendering purposes, but I don't think I'm going to worry about that too much right now. We can take now this this curve, and I'm going to window select all of that stuff, and I'm going to put it onto a layer that I've already made called flow objects. Boom. And we can get rid of those. So now we just have our shank here. All right, beautiful. All right, and we're going to now, I'm going to have to work with this a little bit because of the size differences that I've created here. We're going to make a surface, a plane, corner to corner. Boom. And then look at this in perspective view. Okay, so I'm going to take all of this stuff except for the plane, and I'm going to move it just here. That should work just fine. All right. And now I'm going to use this. Actually, I'm going to move it just a little bit more. Just a little bit more. I want the plane not to intrude into the gemstone space so much. There we go. Perfect. All right, and now we're even going to have separate prongs. This is, every time we do this, it gets a little bit better. All right, so now we're going to use this as a trim object to trim this part of our shank. We'll accept that. We can delete that surface, right? And now we should be able to take all of this, get in the right viewpoint, and we're going to mirror Y. Right? And now we can see, we could join, right now these are two separate objects, but we could join them, but then we're going to have that problem of manufacturing error right here. Possible manufacturing error in the casting process because of this really sharp, acute angle juncture of surfaces. So now we can go ahead and take all of this, including that. What am I missing here? There. Okay, I got them all. Okay, so I'm going to move this over just like negative 0.2. Oops, I must have put 2 instead of 0.2. Let's try this again. Yeah, I put 12, excuse me. Negative 0.2. And that's going to separate those just a little bit. And now we're going to use blend surface, and we're going to chain edges, and we're going to blend that with this. Boom. And we're going to give ourselves a more simple view of this, and I actually accepted it. I'll go ahead and undo that so you can see a little more clearly. So we're going to chain edges again, auto chain, yes. We're going to that surface with that surface here. All right, and I was just going to rotate this around and show you a little bit. We have some opportunities here to modify and it hasn't changed things very much, but that would be the opportunity to modify the blend surface just a little bit if we wanted to. But see what this gives us. Gives us a nice filleted surface between the two things. We'll go ahead and accept that. And now we take these and Control J, and now we have a solid object, and we can check that here by checking volume. We get a nice volume here with no error messages. So we have a nice solid object, a split shank ring with gemstones and prongs float along both sides. Okay, this would be a opportune time to just check and see if we have any questions accumulated so far.
Hey, Gary. It's been going very, very smoothly. The only question that I want to follow up with had to do with the suggestion, to use ZBrush to do the filleting. And I just wanted to remind everybody that ZBrush is a mesh editor. So once you send the ring to ZBrush, it's a mesh. If you try to bring it back to Rhino, you have a mesh. So that would be a reason not to do ZBrush and to keep it in Rhino and do the blend surf like you've done here, or fill and edge or whatever works.
Right. I'm really glad you remembered to say that. That's true, because actually I'm working with a client right now that was working with a designer that created meshes for this guy.
Okay.
And now he wants to take over his manufacturing process. So he retrieved his meshes, but he wants to work in Rhino. And the conversion back to Rhino is pretty complex in some cases, because his meshes.
Sure.
Now Rhino does have a mesh to NURBS command, but for a mesh with, say, over 60,000 poly surfaces or something, it makes it very difficult.
Every face becomes a surface, so it's based on the resolution of that mesh, so it can get really unwieldy to work that way. And this problem is not exclusive to jewelry, because we see this all the time with SketchUp models. And there's been some questions about how jewelry, Pedro asked, can jewelry inspire architecture? I think it goes both ways. Jewelry can inspire architecture, and architecture can inspire jewelry. But the problems are similar that we see in architectures, those SketchUp models that customers try to bring right into Rhino. Now you're dealing with a whole series collection of meshes that are not NURBS geometry and don't have all the properties and capabilities of NURBS. So very similar there. John was wondering what your tolerance in this model is set to.
I think my tolerances are just set to whatever the default in Rhino is. Let's take a look at that.
Okay.
Or wait a second, I don't need to go there, right? I can get to that through GridSnap, right?
Sure, that would work. Yeah, just go up to units. So right under document, there you go, pick on that.
There we go.
Yep, so you have 0.001 set as your absolute tolerance there, and that's millimeters, so that's pretty darn tight.
Yeah, that's tight. Here's the thing, if you're doing modeling and engineering work for a firm other than yourself, like I said, I am doing this all for myself, so I just use a lot of the Rhino defaults. But it's always a good idea to ask what tolerances they need before you begin designing for somebody else. Really important, I think, and that's something Kyle stressed, because he does in his instruction, he does a lot of work for other people, artists and people that are making sometimes more precision and sometimes less precision as necessary. And even in the manufacturing processes that other companies may use, they require a specific tolerance. And so it's a good question. I'm glad it was asked.
And I think when in technical support here, where we see problems is where someone will just take the absolute tolerance and just type in 5 more zeros, and they don't realize that that is now the tolerance that Rhino is going to be using anytime a surface is trimmed, or any Boolean union or Boolean difference, and all of a sudden now nothing works. So all of the trimming and unioning that you've done is no longer working, and that's when we get the models. And then we open them up and look at the tolerance. It's like, wow, there's no way that you can manufacture to this. So usually we say one step more precise than what you're manufacturing to is all you need. But you want to have enough precision, but you don't want to overdo that, because that's going to cause problems down the road. But it could also, if you change the tolerance to be less, than anything you've already trimmed or Boolean will now open up. So it's a really good idea to get a tolerance that works and stick with it, and not play with it, once you have the model where you have it now. There is a question about where to get your gemstones. Do you have a source? I know Food for Rhino has a couple. Do you want me to share those links, or do you have something
No,
specific.
food for Rhino is
Okay.
where I got.
Okay.
Yeah,
Great. I'll
that's
go ahead and share those links, and we'll add them to the landing page as well.
all right. Perfect.
Okay. Thanks, Gary.
Yeah, you bet. I'm just thinking around here. I've scaled my gemstone. This model has ended up a little bit different from the way I've done this in the past. So I'm just figuring out what the dimensions are here. 4.788. So we could call that 4.8 probably, right? 4.8 by 9.5 are now my dimensions. I'm just writing this down because I have a tendency to forget stuff pretty fast. That has nothing to do with being in the business for 45 years. There we go. Okay, so the new dimensions for this marquee shaped stone are 9.5 by 4.8, and we're going to create. Actually, we're going to create the bezel for this thing, and so I'm going to just actually I can leave the gemstone up, but let's hide the rest of this for just a second. That's a handy. It's sort of like a quick hide thing here that we can use. And actually, I don't need the marquee there anymore either, so I'll just go ahead and do that. So 9.5, we're going to create a marquee shape by using an arc. And we're going to, on grid snap, I'll start here, boom, and use relative, positioning, relative, negative 9.5. That didn't seem to work for some reason. Relative, negative 9.5, boom. Well, let's just do it that way then. By golly, more than one way to skin the cat, right? All right, and then we want to come out, what was the other dimension? 4.8. So we actually want to come out 2.4 from here, and that will be right about there. Okay, so there we go. So we can mirror this on the y-axis really quickly. And 9.5, yeah, that's going to be real close to what we need. And we can always modify with history too if we need to. But now we're going to look at this on the, let's see. I think I can right viewport. I created this. Oh, I created that in the front. Sorry guys. That's somehow I managed to get gumball turned off too. I'm really making all kinds of weird mistakes here. That's all right. That's live modeling. You know what? And this is realistic. When you're doing this stuff, a lot of times it's not necessarily, it doesn't look like rocket science when it's happening, but believe it or not, they create rockets with this stuff.
Hey,
so
Gary.
Yes, ma'am?
I think what's funny is that anybody who doesn't present should, because that's where you learn, you know, because you have to be so prepared when you're presenting in front of somebody. Offer to go to a school, present what you're modeling, and you will learn an incredible amount. Plus, you know, you do these things as you're working without even thinking. And then all of a sudden you're in front of the audience here and you realize, you know, how much you do to kind of correct and you know, recorrect as you're moving through the modeling. So
yeah, I'm glad you brought that up. One thing, yeah, exactly. Present, teach if you have the opportunity, because it's really an amazing experience. I've learned so much more about Rhino since I began teaching it that it's been an incredible experience for me. But as you can see, I mean, this
the
is
paradox.
The kind of thing.
Yeah, the paradox of learning. By teaching, you learn, and whether you're in front of a virtual audience or you're in person, you have to be so willing and able to think on your feet. So anyway, you're doing great, Gary. We're sticking with you.
All right, thanks. Hopefully we haven't lost too many people. Anyway, we'll move forward. We're getting pretty close to time, so I'll try and speed this up just a little bit. See if I can not blunder down too many more dark alleys. We will. The next thing we're going to do. Actually, I think what I'll do is boom, marquee gem bezel formers. Boom. Look at this. I'm gonna just bring this in, because I used basically the technique that I used before to create the cutter. I did relative position here, and then I created this bezel former. And this time we're going to create a bezel, so you'll see the sort of process that I aborted earlier on. I've created these walls for the bezel. I've mirrored them in the midpoint of this thing, and we're going to take these two curves, and we're going to sweep 2 rails, and we're going to use these as cross sections. Boom. And we're going to maintain height, because you can see how that changed this. I'll do that one more time. So you can see right now that looks a little funky. It wouldn't really matter, because we're going to cut the bottom of this off anyway. But if we maintain height, that'll be keep it a little cleaner. We're also going to make this a closed sweep so that it goes around both sides, and we're going to accept that. And now we're going to extrude this up. Those 2 curves, you can see that I have selected here. We'll extrude them up using this 1 millimeter, right? And now we can take these curves away because we don't need them anymore. We'll select all those, join those surfaces, and cap planar holes. Boom. And there's our bezel, just that fast, just like that. Now, that was created around a 8x4, so I'm going to have to scale this up just a little bit for our gemstone. Let's bring our marquee gem back. And we'll go ahead and turn this 90 degrees. Looks like that's already plugged in. And let's see, where are we here? We'll align all this stuff. Actually, we can just bring this right down to the center point, and we will just do a shift scale, and that should fit the gem perfectly. There we go. Shift scale is those little boxes that I was using to scale. Shift scale scales it in 3 dimensions, or 2 or 3, Mary. Does it scale in 2 or 3 dimensions?
It depends. If it's 2D geometry, then it's 2D, but if it's a 3D object like this, then it locks into uniform scale in all 3 dimensions.
Perfect. Thank you. I love it. All right. So this is looking pretty good. We really just have one more thing to do, and then we can move on to the rendering, because we want to at least touch with that before we get done. All right. So there's our beautiful bezel, and we talked about cutting it off, and so we will go ahead and do that right now. I have cutters here already from a prior session. We're going to select this. We'll do a Boolean difference using this cutter. Boom. And then we can get rid of those again. And now see how that's really nicely aligned with the interior of the ring. Now, there's one final thing we're going to do here before we move into some modeling. And we're going to take the marquee gem out of the picture for a second. And I have wire cut curves already made for this purpose. But I'm going to scale them too, just a little bit. I'm going to take these curves, and I'm going to scale those just a hair. And that should be really nice. Okay, so let's look at this in side view. Okay, so we're going to have to pick one of these at a time, or I probably don't even need to pick it now. We're going to do solid edit tools, wire cut. We're going to do this, select objects to cut here, except we want to cut all the way through, and then we can just delete that, And now we're going to do the same exact thing over here. Select objects to cut. Going to cut all the way through, and then we can delete those. And now we can hide those wire cut curves. And now we can bring back our marquee gem. And now we'll talk a little bit about, let's get rid of all of our gemstones for a second, because we're going to create some materials for this. I'm a yellow gold guy, so that's probably what we're going to do here. Marquee gem, get these off. Okay, so we'll just select all this, or we don't need to yet. Hit the materials tab. We already have a metal made. I'll show you what that looks like. It's a metal. The color is gold. I have it polished with no bump texture. So if we just select all these things and right click here, we can assign it to objects, right? And then if we look in rendered mode, that's what it looks like. Now let's bring our gemstones back. Go back to the layers tab. We have the round gems and we have the marquee gem. Oops, there we go. Okay, in rendered mode, you can just barely see these things. In fact, I may have to select these gems. Let's see what this looks like in ray trace, though. I think I need to apply a material to these guys because these were they haven't had the right material applied to them yet. So ray trace is the best render mode that Rhino does, and it gives you a very high resolution image. But it's not rendering the round diamonds real well right yet. So I'm going to get back into shaded view. I'm going to just shift select these guys real briefly. And if I had made them into a group, it would be easier to select them. But we'll go to the materials tab. Is this the right one? Diamond. Yes, we're going to apply assign to objects. There you go. And I think now, if we go to ray traced, yeah, now they will render real nicely. Nice bright things. Move this up. Okay, so the ray trace mode takes a minute. You can see the counter down here on the lower right corner. It's going to do 1,000 passes. Here you can see the elapsed time. We're at 12 seconds, 13, 14, 15. It'll take it about 3 minutes to get the absolute finest image that we can get. But you can see after only about 75 passes here, it's starting to look very good. Now this diamond material is actually built right into Rhino. While we're waiting for this, let me just show you how we can material. I want to add a material here, and I'm not seeing my little plus button. There we go. Boom. So we can add a metal, a glass, a plastic, or a gemstone. So the way we created this diamond rendering was to just click on gem, call it a diamond. But if we wanted to make these, let's say, for example, let's make this an emerald, and then let's select this, and here we go, boom, assign to object. All of a sudden we have an emerald center stone that's nice and brilliant. So assigning materials, making materials, and assigning materials have gotten much easier in Rhino 6. And I have to say the render engine is so good now in Rhino 6 that you probably won't need any kind of outside rendering engine, because this is plenty good enough to show to a client. Now, if you want to, there's a couple of ways to get to how do you send this to a client. without sending them your Rhino file, there's a command up here called view capture to file. Oops, you got to view capture to file, and you're going to get, all right, let me back up through that again. View capture to file. And it takes a second because we're in ray trace mode. But then here on this screen, you can see if you want to bring in the grid, world axis, C-plane axis, transparent background. You want the resolution to be the viewpoint, but you can do the scale and resolution here. You can select what that's going to be. And then if you click OK, you have the opportunity to save it wherever you want to save it. We'll back out of that. I'll just show you my little hack though. Sometimes if I don't necessarily need a real high resolution thing, what I can do is reduce this, and I can use the snip and sketch tool in Windows 10. Works really good actually. Just show you what that looks like. And boom. Okay, so you can just do a new and grab that sort of as a screenshot really quickly, right? And then save it. We can back out of that. But that's sort of a quick and dirty hack to be able to send JPEGs to your clients. This, you can do the same thing, basically. The view capture to file does pretty much the same thing. But you can make a much higher resolution image with view capture to file. Okay, so do we have any questions built up? Where are we at, Mary?
Hey, Gary. So why don't we ask anybody who wants to ask a question, go ahead and throw your hand raising icon up so that we can unmute your mic. And while you're considering that, hopefully we'll get a few live questions. Let me go ahead and go over the questions that we have left that have been chatted. Sophia asks, how much do you reduce the bezel for 3D printing? Was it minus 0.5 millimeter?
I think she may be referring to offset.
Okay.
And you know, it depends entirely on the scale of the gem.
Yes, she agrees. That's what she was asking.
Right. 0.4 millimeters is about the minimum. On tiny little round bezels, sometimes you can successfully print and cast maybe down to 0.3, but sort of 0.4 millimeters is a great standard. And actually, this is a really great time to bring up that link to best CAD modeling best practices.
Right. Okay.
Let's talk about that for a second, Mary. CAD Stuller website.
Do you have it there, Gary?
I don't have it here.
Okay.
I didn't think to bring that up. I can get to it pretty fast, actually.
Okay, why don't you do that? And then while you're doing that, I will go over the next question. Just a little bit of multitasking. Miguel asks if you have any advice about SLA printers, entry level, low cost for beginners.
Low cost LED or
SLA.
LED or SLA printers.
Yeah.
Well, we have SLA printers, which typically refers to a laser light engine. They're a little bit slower than DLP, which is digital light processing. And then we have now we have LED or LCD printers also, and they all print with resin. And I'm a little remiss to call out a favorite because the technology's improved such that there are many good ones on the market right now. In a lower price range, you could look at Solus or Frozen. I think, are two that kind of stand out as being really good. I know Solus has really great support. Not 100% sure about Frozen. I haven't worked with that company at all. You know, you could step up then to MeCraft and or B9 in a slightly higher price range, and those are both DLP printers. Form Labs has a really great printer that's an SLA printer. But you know,
That's good. No, the forum is actually an excellent place for that question because it changes over time, and the support forum becomes an archive of answers. So
I'm glad you mentioned that.
Yeah,
And, you know, I'd be remiss to call out a favorite, really, because like I said, the technology is evolving so rapidly. Probably a month doesn't go by where there's not one or two new printers on the market. And the technology has evolved so rapidly that a lot of those are really good. I will just say that do your research on the forums and find out. I mean, support is as important as the hardware. And it's
true.
It's been a huge issue for a lot of people that jump into this technology and then they can't get support necessarily for the printer that they purchased, and you can easily get into a quagmire there. But again, I mean, there's a lot of good. It depends on how much tinkering you want to do too. Some of these are very hands-on. Some of them are plug and play. And you'd be well advised to just do as much research as you can.
And the forum they're pretty friendly. So you're going to get a lot of suggestions and advice. So if you haven't already gone out to the support forum, I'll show that link here in a moment when we grab the screen back and go into closing. But one more question, Gary, about showing naked edges. Do you want to show the show edges command? And then we'll go down the list here. We do have a couple hands raised.
Okay, great. You can check a model pretty easily. Let's select this and select the bezel surface that we created here too. And there's an analyze edge tool, show edges, and then you can show all edges. And what you really want to be concerned with here is naked edges. And see, we've done a good job modeling here because I'm not seeing any naked edges in this model. Everything is a nice solid. Now it's not, this is one solid, this is one solid, and each of the prongs are also separate solids. But there's nothing there so far that is non-manifold at all. So we're in good shape. Another thing, it looks good. The other thing that I demonstrated a little bit earlier though, and it's a tool that early on I started using, so I still sort of default to that. You can do an analyze mass properties and get a volume. And if you have any naked or non-manifold edges, you'll get a little screen here that says, do you want us to go ahead and calculate the volume anyway? Something like that. I paraphrase here, but you know, these are not manifold. This object is not manifold. Do you want to go ahead and calculate the volume anyway? And if you don't get that though and get a volume up here, you know you're in pretty good shape.
Great. There's also a question about whether you have to union this all together and 3D print it, or are you ready to 3D print it right now because all the objects are closed. There's also a command that I just thought of, a cell closed polysurface that you can use to make sure that everything is closed and ready to go to the 3D printer.
Cell
closed polysurface. There it is.
There we go.
Yeah.
Okay. So yeah, if everything lights up, you're good, right?
Then it's ready to go. I think that's a surprise that a lot of users have. They're under the impression that everything has to be one closed solid to 3D print it. When we have an Ultimaker here courtesy of the wonderful Ultimaker people and the Cura software. It's happy to take in a collection of closed objects, and then the software Cura works to kind of bring them together and send out a mesh for slice it and send out the data to the 3D printer.
Right. Let me add to that. It depends on the printing technology that you're using. The piezoelectric ones that I'm familiar with, and again, SolidScape comes to mind as one of those. I'm spacing out on the other prominent one. But those typically do require one solid closed object. So you would have to Boolean all this together into one object.
Interesting. Okay, that's
in order to print
a good distinction
on the wax printers. Now, almost every, as far as I know, every resin printer, both the DLP and the SLA and the new ones, the LED printers, will print overlapping solids. They won't print something that's not closed, but you can have solids like we do in this case, in the case of this, that are overlapping, and it will see it, it will slice it and print it just fine.
Great. Okay. Let's go ahead and open up the floor for questions. So Javier, you're the first one with your hand up, so we're going to go ahead and unmute your mic. Are you ready, Gary?
Yep.
Okay, super. Here's Javier. Javier, if we'll give you a few moments to play with your mic. And if we don't hear you, we will come back to you shortly. We'll see if he can get his mic going. Okay, Sophia, you're next, so let's go ahead and unmute you. Hopefully we'll hear your voice here shortly. Hey, Sophia.
Hello, how are you?
Great. Do you have a question for Gary? Yes, we can hear you.
Okay, perfect. No, I just wanted to know about the offset and the measurements Gary uses for 3D printing. How much the numbers are important for me to try myself and to see if I get the correct one when I am 3D printing a ring, basically.
Okay, I think I understand the question. You want a little more discussion on the perhaps best practices and production standards for offsets and scaling to successfully print 3D. Let me just preface the discussion on production standards that I have up on the screen here with the idea that one huge benefit to having a 3D printer on site is that you have the ability to, like, just for example, and I do this a lot still because it's offsets and scale is sort of a moving target to a certain extent. Every design may require slightly different thought with scaling. There's no one magic number that works across the board. As I said earlier on, Travis and I are in this discussion right now about the idea that I came up with, that it seems like with my system, which I have a DLP printer, an older DLP printer, it seems like the scale factor for the shank, for the ring size, is different than the scale factor for the bezels that I make. I use about the 1.1, 1.2 scale factor to get the ring size exactly where I want it for printing. And I use up to 3% scale factor on smaller objects like bezels with the 4 offset, with the 0.4 millimeter offset. But if my screen is still visible here, I just pulled up that PDF from Stellar, and you'll see here that they talk about file types. Now, what they're trying to do is coach you to how to design for their production standards. So you have to bear in mind that that's what they're trying to coach. But what I've found is that their best practices here are actually a good starting point. They're actually a pretty good starting point across the board. So you can get this from the Stellar website, and I'm sorry, I'm remiss. A quick search, I had to kind of dig for this on the Stellar website before, and I wasn't able to find it really quickly, but I did save off. You can download it. So I saved off one that now we're looking at in the screen. And you can see here that they have really good and well explained standards. The minimum distance between a gallery rail bearing, for example, is 0.4 millimeters. And they came up, you know, mine 0.4 millimeter offset for a bezel was just, it was hit or miss for me for a while, but I came up with that number as something that worked really good for me. And we will see as we cruise down here that Stellar agrees with that. They decided that prongs should probably be about 4 millimeters in diameter. Thicknesses of a bezel wall has to be at a minimum of 0.45 millimeters. You can see where my cursor's orbiting here around that number. Bead setting on a channel, you know, the beads must not be touching, minimum spacing, you know, they go right down the line here on best practices. And the thing is, like I said, bear in mind that this is a starting point for if you have a printer on hand, you're going to have to do a little bit of your own research to figure out what's going to work for your particular system. Hopefully that answers the question pretty good. And I think I'll figure out where this link is and shoot it to Mary, and she'll put it up on the website.
Oh, hey, Gary, Philip already did. So yeah, so we have the link, and I've shared it a couple times, but I'll also put it on our landing page as well, so it's easy to find for after the presentation.
Yeah, so, fantastic. Yeah, and I'll just say one more time, I mean, this isn't necessarily gospel. Your system may require slightly different standards, but this is an excellent starting point. Great. Thanks for doing that, Philip, by the way.
Okay. Well, do you have anything final to share on your screen, Gary, before I grab back presenter?
Well, I think we've done what we accomplished to do here. I don't really have anything else prepared to show. I'll just kind of close out my part by saying, first of all, thank you all so much for attending. It's a lot of work to prepare for one of these things, but it's also a lot of fun. And I appreciate you all being here and showing interest and participating in the conversation. And have fun designing.
Great, Gary. So there are a couple last things as we move into closing. This is the Food for Rhino website, which if you haven't done a quick registration out here, you won't be able to download. But I believe these are the gems, Gary, that you used. Here there's a free set, and then there's a low-cost set.
Right.
Okay.
Actually, mine there's the free set.
The free set. Okay. Yeah. Great. So those are out there for you, and then we'll add the PDF download link to this page, and let's go ahead and move into closing. It doesn't look like it looks like there are no further questions. So this webinar was recorded. We'll do a little cleanup on the video and then get the video out on that landing page. And Gary wanted us to mention he has a level 1 Rhino class coming up. It is an online class. It's presented over 7 weeks, and there's 1 3-hour session per week, and that's to give you time to master skills and to come back to the next live session and ask questions. So we wanted to make sure that you knew about that. And I think it's pretty funny, Gary. One of the comments was, when is the next live webinar? So maybe if you're willing, we can get you back to do another one of these in the fall. So many thanks to Gary from all of us here at McNeil. All the time he spent preparing and practicing and actually delivering the presentation adds up to be quite a bit out of. And also we want to thank you for spending part of your day with us. It might have been the morning, it might have been afternoon or evening, but if there are no further questions, then we're going to go ahead and close out. So have a great day. You'll see the video here shortly and get a follow-up email from Rhino instructor. Bye now. Bye, Gary.
Bye-bye. Thanks a lot.